So this is talking about the reactivity of metals. So we've been talking about metals really because metals are those things that are, well, not just metals, but metals are ions, or they can have ions of themselves, and they can conduct electricity. And all of this is really related to losing and gaining electrons is related to electricity. So it says the reactivity of metals. Some metals react more readily than others. Those that are more stable do not react, and they tend to be of greater use because they do not undergo corrosion. So there's some metals that are better for us to use in like buildings and piping and all that stuff because they don't react as much as other metals would. It says metals that are highly reactive, such as iron and copper, tend to give away electrons, and they have a lower electronegativity. Metals that are more stable, such as gold, tend to hold on to their electrons, and they have a high electronegativity. Have you ever had like any type of jewelry that's like not real gold or silver? Like cheap jewelry?
Jason does all the time.
You don't? Well, if you ever have had like cheapish jewelry that's not like real metal, or it's just plated, it'll tend to like sort of tarnish, it'll turn green. And that's because it's losing electrons. So a more stable, with a high electronegativity metal is going to be better for some sort of jewelry because it's going to stay looking the same. Like this ring I have, well, it's not very expensive. It's $25. This $25 silver ring, at least it's silver, right? So it's made fully of silver. It's not going to tarnish as easy as some other types of metals. Okay?
Question maybe at the this.
I don't know. I think it's not. I think you're supposed to be on 5 or 6. Like the stuff about spontaneous, that's what we're talking about right now. So the question is something about spontaneous. Question. So look at this page that you got. On page number 4 of your data booklet, in that chart there, and I guess I could, because this is being recorded, I can show you this. But you can see this chart. At the very top of the chart is gold, AU. So that's the least reactive metal. It's the one that is going to be pretty stable. And then if you go all the way to the bottom, lithium, it's going to be the least stable. So if we had lithium metal, it's going to corrode really easily. If you put it in the air, it's going to like turn tarnish, I guess you could say. Silver should be high up there. Yeah, it's the third one down from the top, Ag. So that's why we make stuff out of silver and gold. Those are more precious metals because, well, they're less reactive. Okay. So I'm just going to keep going on this. I guess I should show you about this. So electronegativity, if we go back to this slide here, it says something that is a metal that's highly reactive has a low electronegativity, and something that is stable has a high electronegativity. So the numbers, so electronegativity, higher it is, the more stable something is. So if we look at these two, we've got gold and copper. This is the Bohr diagram of them, like the full Bohr diagram. So imagine, I never made you draw ones that are that big, because that's way too many circles to draw. Especially if you'd have like, they weren't perfectly spaced out, you'd have to like fill a whole piece of paper. But basically, if you look at gold, it's actually got one electron, I guess, in its outer shell, and so it's copper. So that doesn't really tell you much about it. I think it's just showing you that atom, but basically those more stable ones have a higher electronegativity than things that are less stable. And we'll touch on that as we keep going. So there's a picture, or there's a video there that doesn't exist anymore, so we're just gonna continue going. So how are we comparing the reactivity of metals and metal ions? It says elements always react in a way that increases their stability. So things always react to make themselves more stable. Everyone wants to be stable. Who's the most stable on the periodic table?
Gold.
Not gold. That's our most stable metal. What is our most stable element on the periodic table? Everyone wants to be like them. They're the coolest.
Helium.
Huh?
Neon.
Yeah.
Argon.
Yeah. What are those things called? Do you know what their name is?
The upper class.
They're the upper class. They're the noble
There
gases.
you
So the noblemen, the upper class. There you go. So everyone wants to be like them. They're the coolest people, and they are the ones that are the most stable. So everyone wants to be like them, so they react with other things to be more stable. As a result, a very predictable trend emerges when we compare the stability of metals and their metal ions. So metallic elements that are very stable as a neutral atom tend to be very reactive as an ion. So Au by itself, so that's gold, solid gold, very stable, but Au with a positive ion is highly reactive. Yeah.
Was there something on the bottom of the line?
No, it was just, I can double check. No. But Maddie took some before me. It says metallic elements that are very stable as ions tend to be very reactive when they're neutral, so copper, very stable as an ion, but very reactive when it's by itself. So this brings us to this table that you guys have in your data booklet, the ordering of the reactivity. It's called the activity series. So based on the way metals and their ions react, when combined with other metals, we can create a table that organizes the metals from most to least reactive. Because ions cause other substances to undergo oxidation, they are referred to as oxidizing agents. And all of the oxidizing agents are listed on the left side of the table. So if I zoom in on that, so it's really blurry. It's not helpful, but so all of the things on the other side are the oxidizing agents. They're the things that cause stuff to oxidize. And then on the other side of the table, those are the reducing agents. So those are the things that help things to be reduced. Okay? Not too important that we know the oxidizing and reducing agent terms, but it is important that we know that what it says on here. So the most stable metal or solid is at the very top, so the top right. A solid is the most stable, and then Li solid is the most reactive. And then on the other side of it, the left side, Au, the ion is the most reactive, and most stable is Li as an ion. Okay? So the way that they react is to become more stable, and they'll always try to be stable. Using the activity series to compare reactivities. So the most reactive ion is listed at the top of the table on the left side. Okay, I just said that. Let's just keep going. So it says what is more reactive, lead ions in solution or sodium ions? So we gotta look, if we're dealing with a question like this, we're looking for lead and sodium. We gotta look at this page. Do we even know what the symbol is for lead? It's a hard one. But that's going to be a first step in figuring out where lead is on this table. Yeah, so I did write it up here. So PV, lead, that's what we're looking for, and we're also looking for sodium. So we want to see which one, sodium is Na, which one is more reactive as an ion. So the ions are on the left-hand side of the table. So whichever one is higher up is going to be more reactive. Okay, so which one's higher up, lead or sodium? Lead. Perfect. So that's all we would have to do in a question like that. Is literally just compare them in the table, but really important that you remember. And if you want to write on your table, like inside of this, if you want to write at the top most reactive to least reactive, and then that can help you. So just like what it says on here, see what it's written in red, it's sort of blurry, I'm sorry, but it says most reactive is AU plus 3, and most stable is Li plus on the bottom. Because you're always going to use that data booklet, and I don't care if you use that on a test, so write on it what you need. Alright? So we said lead. Okay. And then what's more reactive, solid lead or solid iron? So solids are on the right-hand side of that table, so we're going to look for solid lead. Solid lead and solid iron. What is iron? What's the symbol for iron? That should be in like the 20 range, I think, on the periodic table. Around the 20 range? Maybe I'm sending in the wrong direction.
Fe,
Yeah, is it not in the 20 range?
26.
So it is in the 20 range. I'm not lying. It's like it is in the 20s. Fe. So on the right-hand side, the more stable one, this is the most stable is at the top, and the most reactive is on the bottom. So the question asks me what's more reactive. So we want to think that's less stable. So it would be something that's lower on the table. So it's PV lower or Fe? Fe's lower? Yeah, Fe's lower than PV.
C.
So we would write iron is more reactive than solid lead. So if you think back in the past, we now know that lead is bad for us, but they used to make lots of stuff out of lead because it's not as reactive, right? It doesn't corrode as bad as iron, for instance, where you would see like a greenish tarnish coming over it. You know, like the Statue of Liberty? Do you know what it's made out of?
Probably.
It's made out of copper. But copper is really pretty reactive as a solid.
That's why it's green.
Or sorry, as an ion, so it turns green. Yeah. That's why it's green. It's actually supposed to be not like green. If you have a really old penny, which we don't have pennies anymore, but they started turning green too. Have you seen them?
I thought a few pennies.
Do you? I found some pennies the other day and they're all American. So
My grandma had a jar full of pennies.
still,
Yeah.
just for no reason.
She's
I
like,
think they're gonna be worth something someday.
she left it at our house. Friday night.
Yeah, I found pennies in my house and they're American, and then I kept them because I'm like, well, next time I go to the States, which will probably be like many years from now, because we'll never be able to go. Because in the States, they would never, back in the day when Canada had pennies, they wouldn't even take Canadian pennies. So when you go to pay for something and it's like, I don't know, 1 cent, like $5.01, they'll give you 99 cents back, and it's really annoying. And then you get all these pennies. Just accumulate pennies when you're in the States. Anyway, that's off topic. So using the reactivity series, how do we predict if something is spontaneous? So it says a spontaneous reaction is one that occurs without the need for any additional energy. This is one of your questions, I think, in your review. It says the activity series can be used to predict whether a reaction will occur spontaneously or not. If the oxidizing agent, so the ion, is located above a reducing agent, which is the atom or the solid, for a particular chemical equation, that reaction will occur spontaneously. So super important thing to remember. This right here. Just circle around if there's something that you'll need to remember when you're doing these types of questions. So if the ion is located above the atom in our reaction, and We'll do an example of that, I'm sure, on the next slide. If the oxidizing agent, which is the ion, is located below the atom on a particular chemical equation, that reaction will not occur spontaneously. So let's do an example of that. So the example is, will a reaction between solid aluminum and copper ions occur spontaneously? So solid aluminum, what's the symbol for aluminum? What did you say? Al. So we're looking for Al solid reacting with copper ions. Copper is Cu, and it's an ion form. I don't know if it's +1 or 2, doesn't matter. So we need to look for those, and if we go back to the last slide just to refresh, the ion has to be located higher than the atom for it to occur spontaneously. So our ion here is copper. So we need copper to be higher up in the table than aluminum. So if we see right here, that's copper. Copper is like the fourth one from the top. Aluminum is way down here, way lower than copper on the table. So because that copper is our ion in our reaction, will this be spontaneous? Yes. So ions always have to be above solids. So we would just say spontaneous. So will a reaction between solid silver and zinc ions occur? So silver, what's the symbol for that? Do you know what was it? Ag, and that's a solid. And zinc ions. Do you know the symbol for zinc? Cn, Zn, and then that is an ion, so it's got a plus charge. So we want to look for Zn. Zn higher up than Ag. So we look at our table. Zn is there, Ag is right here. So is Zn higher than Ag? No. Yep. See the Ag right above Cu? So pretty high up. Zn middle / bottom. So Ag is higher than Zn. Zn is our ion. That means that this will not occur spontaneous. So not spontaneous. Okay? So you're not doing much on these questions, you're just reading a table and using that table to figure out how to do it. So here's some practice questions. So it says determine whether each of the following reactions will occur spontaneously or not.
Please.
Do these together and then you guys can
Did you
do some on your own.
get your, or did you go to Habima
A
yet?
brick of gold. Symbol for gold. We always gotta know the symbols because that's all they have in the table. What?
Yeah.
you saying you're stupid?
You,
It's Amy. Why are you saying you're
Yeah.
stupid?
because I didn't know I was.
Oh, that's fine. It's not, doesn't make you stupid. You got a table that tells you.
No, you have to.
You don't have to
Send me
know
over.
these, but I
Comment
mean,
down.
like, as we do more and more, you probably will start to
Okay.
remember, right?
Right.
Like, I don't need to look up, I think, any symbols anymore now that I've been doing it for so long, but.
What is?
Silver.
What is fermion? Exactly.
I think I don't think I've ever heard of that one. But the ones that we use.
What?
What are you doing right now? Are you paying attention? Okay, so a brick of gold, AU. Brick of gold, is that an ion or is that solid? Solid. So it's a brick of gold with plain silver nitrate. We don't care about nitrate, we just know it's a solution. Silver is Ag, right? And that's our ion. Is that gonna be spontaneous? Is Ag higher up than AU? AU is at the very top, nothing's higher than AU. So is this gonna be spontaneous? No, not spontaneous. I'm just gonna write NS. Now on spontaneous. A piece of iron. Iron is Fe. It's a piece. That's a solid. In a copper 2 sulfate solution. Copper is our other one, which is an ion. We're only looking at metals here, so sulfate doesn't matter. It's just a metal. Is copper higher on the table than Fe? Copper is right here. Fe right here. So copper is our ion, it's higher up than Fe. That means that this would be spontaneous. So because our ion goes above our solid, it's spontaneous. Good? Holistic? Have you been paying attention to any of this?
Yeah, I was
I don't think so.
looking at the book
Okay, I didn't see that. That's
until like 5 minutes ago.
until 5 minutes ago. Perfect. A piece of zinc. What's the symbol for zinc? What is it? Do you know?
Yeah.
That's a piece, so that's our solid. Is in a solution of sodium chloride. Sodium symbol.
Hey.
Na. That's our ion. So we need to check our table. Is sodium higher than zinc? So we go to our table. We look for sodium. Sodium, I don't see it. Oh, it's almost at the bottom. So is sodium higher than zinc on the table? No. Sodium is like right there, really blurry, but there. Zinc is higher up. So non-spontaneous, I just wrote NS. Okay? NS is equal to not. And then the last one, aluminum symbol. Al. An aluminum fishing boat floats in a lake with a high concentration of iron ions. Symbol for iron. Fe. It's iron too. Doesn't really matter. We go back to our table. Is iron higher up on the table than aluminum? Iron. I see. Where is it? Iron's here. Aluminum here. Iron is our ions, it's higher up on the table. That means spontaneous. Good? Yeah. So I'd like you to